In this video, we're looking at expected value. Now, this comes in two contexts. The first is worded problems like this. So if you're playing Pokemon, you've got this base chance of getting a critical hit. I have simplified a little bit from the actual game, but that's the idea. I'm going to do 30 attacks, and I want to know how many critical hits I'm going to get. So really what I'm asking for is 6.25% of 30. That's really the question I'm asking. Now, the way that this works is when you plug it into a math formula, 30 is 30, believe it or not. When you plug a percent in, you do need to use the decimal version. So that's 0.0625. You can think of the percent symbol as actually being like out of 100, and then that is 6.25 divided by 100 is that decimal version. Anyway, the word of always means times in math problems. So that's really what I've got to work out. Now, if we open up a calculator, we can get that answer. So we're just going to go 0.0625 times 30. 1.875. So it's about 2 out of 30 moves would be critical hits. So, this could actually be useful if you're, if you were running a competitive Pokemon tournament and you saw that somebody got 15 out of 30 moves as critical hits, you might suspect something might be going on. Maybe they're cheating somehow. I don't know. Okay, next we look at this in the context of a PDF. So we've got this class and we're surveying on the number of pets. So we could make a PDF table. So like let X be the number of pets in the class or owned by a student in the class. So then you could say little x and probability that big X equals little x. So it could be 0, 1. We don't really need 2 on the table because nobody had 2 pets. So how many people were there in the class? 1, 2, 3, 4, 5, 6, 7. So there's a 1 out of 7 chance they have 0. And there's a 2 out of 7 chance they have 1. And there's a 4 out of 7 chance they have 3. Now, we want to calculate the expected value, which is just another way of writing the mean. Now, the way that we would normally do this let's just call this the old method, is we'd add up all the pets. So 0, 1, 1, 3, 3, 3, 3, and we would divide by the total number, which is 7. So what would that give us? That would give us 16, no, I lied, 14 over 7. Or 2 is the average. The new method, and the formula we're going to use for PDFs, is it's the sum of each data point times each probability. So what that actually means is 0 times 1/7, 1 times 2/7, and 3 times 4/7. And algebraically, it's a good exercise to check that's actually equivalent to what we were doing over here. But what this will become is 0 plus, that'll be 2/7, and then that'll be 12/7, which would give us again 14 over 7, which is 2. So the new method is much, much better than the old method because it accounts for like weighted probabilities. And you imagine if this sample was like 500 people, you'd have a really rough time doing the old method. Next, we're just going to check if this game is fair. So another really good use for expected value is like games of chance. I do not recommend that you play games of chance for money in real life, but you can use it to figure out if those games are fair. So the friend gets you to flip 3 coins, and if you get 2 heads, you win $3, but if not, you pay your friend $1. So last video, we sort of made this PDF of flipping 3 coins. I would encourage you to see if you can replicate that, but just as a reminder, we sort of like did a tree diagram and got all the probabilities. The reason this is 1/8 is this would be 0 heads, so that would just be tail, 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 which has a 1/8 chance. This is 1 head, so you could get head, tail, tail, head, tail, tail, head, tail, and tail, tail, head. So that's why the probability is a bit bigger there, because there's more ways to do it. Anyway, we need to calculate our expected winnings. So I'm going to say let y be the winnings. Okay, so we want to make sort of a PDF for y based on the PDF for x. Now, if X was 0, so that's 0 heads, you didn't get 2 heads, so your winnings were -1. You lost $1. You paid your friend $1. If X was 1, you get 1 head, you've also paid your friend $1. And if X was 3 heads, you've also paid your friend $1. The only difference is if X was 2 heads, you win $3. So you get the $3 back. So if we want a probability distribution for Y, you could have -$1 that you win, or you could have $3 that you win. And if we look at the corresponding like probability for this, I might just do it over here. So this would be the probability for 0, so that's an 1/8 plus, and then the probability for 1, so 3/8 plus, and then the probability for 3, so 1/8. So that is, what is it, 5/8? And then the probability down here would be 3/8 for X being 2. So that is how you get the probabilities for each one. And let's see. So -1 had a 5 out of 8 probability, and 3 had a 3 out of 8 probability. So the expected value of Y is -1 times 5/8. So 5 out of 8 times you lose $1. And we've got to add on 3 times 3/8. 3 out of 8 times you win $3. You can do this on a calculator if you want, but it ends up being 9/8 take 5/8. I've just swapped the order of those two things, which is 4/8, which is 50 cents. So should you play this game? The answer is yes. On average, you win 50 cents. Yeah, I can tell you that if this was a game in a casino, either they wouldn't run this game or the casino would go out of business, because any casino games have a negative expected value. So we could say something like expected winnings from a game in a casino is definitely negative. Otherwise, the casino would go out of business. This is how they make money. So for example, you could bet like red or black on like roulette. And you would normally have a 50% chance of winning or like doubling your money. So the casino wouldn't make any money on this game. And I encourage you to think about maybe what causes the expected value to be less than 0 for you for winnings. Before I just tell you, pause the video if you want to do that. But the reason is because they have these, so it can hit these and then you just lose. So that's the way they get it slightly under 0. The other way is, for example, in games like blackjack, if it's a draw, the casino wins. Otherwise, you would have the expected value equaling 0, because you sort of as likely to win at blackjack as you are to lose. So the casino there makes money on you drawing. Not to mention, this doesn't seem too bad for the casino if the expected value is 0, because they just sort of gain as much as they lose. But you have to remember they're also paying their employees and their electricity bills and stuff. So the casino wants the expected value to be less than 0, so they make money.